Hello, my name is Diana Chan, and I am a chemistry tutor at the Natural Social Science Lab at Miami-Dade Kendall campus, and I'm going to go over the second example. In the last video, we discussed how to find the average atomic mass given that the isotopic masses and their abundances were provided. I mentioned to you about how your teacher could give you a scenario where you would need to find the average atomic mass, but it is not an element given on the periodic table. Example 2 is such an example. Pretend you are on a planet, Krypton, and they have discovered a new element, Lex Luthor. You have canvassed all the isotopes of this element. There exist only 2 isotopes of this element, and you have compiled their atomic weights and their respective fractional components in this chart given. So we see here that there's the isotope 299 Le and 305 Le. Their percent abundances are 66 and 34% respectively, and their atomic masses are 299.2 and 305.05. In this example, you cannot just assume the number on the periodic table, which would have been easy from the question in the first example, but it can still be easily solved. So here again, I've provided the formula from Module 5. It's the average atomic weight equals percentage 1 times atomic weight 1 plus percentage 2 times atomic weight 2. And I'm just going to plug in the percent abundances and atomic masses into this formula. Now remember, I like to change these straight from percent abundances to decimals just to make it easier when I type it into my calculator. This could also be 66 over 100 or 34 over 100. So you can either do it as in the fractional form or the decimal form. Now, doing some simple arithmetic, I can simplify these two parentheses, and with some simple addition, I get, so the mass number of Le, or Lex Luthor element on planet Krypton, is 301.189. And this makes sense, right? Because we have more of Lex Luthor 299, which is 66%, versus less of the Lex Luthor 305, which is 34%. So, looking at a little timeline, we would see that the average atomic weight should be closer to 299. Because there is 66% of the smaller one, it would make sense that the average of these two items would be closer to the smaller one. If pretend we didn't have these percentages, but we had 50% and 50%, the average would be right in the middle, or 302.35. But because we have more than 50% of the smaller isotope, we would assume that this number would lie to the left of this 302.35 average. That's how you would solve the problem intuitively if there was some, let's say, multiple choice. But now that we've gone over how to solve the atomic weight, the average atomic weight on a different planet, next we'll go through how to work out a problem to find the each isotope's atomic weight, or one of the isotopes' atomic weight, in the next example, example 3. I hope this video has been helpful.